Thank you. So backend engineering. So basically, backend engineering means we design, build, and maintain server-side applications. Front end is what basically a user sees on their phone or a site, but backend is everything behind the scenes where there's business logic, where there's infrastructure, where there's data manipulation, and many other things. That is something that the user doesn't see, which is considered backend. Some of the concepts that are a part of backend engineering or overlap with this domain is knowledge of client-server architecture, networking, APIs, web development fundamentals, microservices, databases, security, operating systems, etc. There is a big list. Some of the technologies that would be considered backend side would be Java, PHP, .NET, C#, Ruby, Python. On the API side, REST, cloud would be AWS. Backend again, framework would be Node, and databases would be SQL, NoSQL. System design. So let us understand like what is the system design first, right? Basically, you want to design a system or do design to solve a problem that exists or build a new product or a new feature, right? So in system design, what we are trying to do is we are trying to define an overall architecture. We are trying to define what the modules are, what the interfaces will look like, and what is the flow of data through the entire system. Now, what does these words mean, right? Like, what does it mean to define the architecture or design the interface, right? So let's break it down. Architecture means you need to define the overall behavior and view of the system. This might be slightly the high level, and then you dig deep. Modules is where your entire system is comprised of specific modules. Each correspond to a specific task or functionality. And all these modules interact together and communicate together to build, for your entire system to function. And that is what the communication between these interfaces is basically what an interface would be. And data flow is, every system deals with some kind of data collected from the user or from different systems. So in system design, something which is very important is the flow of data and information through your system between different modules and also between systems. So in system design, what you want to do is you want to define the input, you want to define the output, you want to determine what the business rules or business logic is, and also the data structures and data schema. There are some design considerations that we need to keep in mind for any good system design. These are the general topics or design considerations. There can be more, but this is something that's, these are the considerations that are like absolute important. Just bear in mind that these requirements or expectations can vary from team to team and product to product and company to company. But this is basically, these are considered basically best practices for design considerations. So first thing is scaling. So as your system grows, as you add new features, as you collect more data, deal with more data, your application should be able to swiftly deal with those demands and still perform as expected. And this is basically what scale or scaling means. And this brings a lot of different design challenges and requirements, but as your application grows and you deal with more data, it still needs to be performant. And that is something that is solved when you think about scale or scaling. Availability is you have a system, it has to be running, it has to have a proper uptime. If there's a downtime, it needs to be managed. For example, your website is under maintenance. You would not want to have a maintenance time during a peak hour, maybe during like middle of the night when nobody's using your website, stuff like that. So you need to define what your system uptime is, what does that mean, and what does downtime mean? So how available is your system and what does that look like? Reliability would be the system performs the task as expected. So you design your APIs, you design your data schema, you build a system now, it needs to perform as expected. So you need to think about things where there might be situations where your system might not be completely reliable. What would that look like? And how would you address that? So you need to focus on that. Robustness would be if your system is functional when errors or disturbances, right? So you can think about error handling, you can think about exception handling, you can think about happy paths, unhappy paths, any kind of disturbances, that's something that comes under the radar of robustness. Load balancing is somewhat related to scaling, where as your network traffic grows, as you add more and more servers to your system, or even more databases, your system is grows and is more distributed, there might be an issue of managing network traffic or traffic in general. That's where you need to think about load balancing based on, there are certain criteria on how and why we need to do load balancing, which we'll look into detail in part 2 in the next session. But you need to properly manage your system load, and that is something to be considered for sure. Caching is data storage layers. So caching is you can store your data in 2 different ways. One is in the database and the other is caching. Caching is optional. You may or may not need it, but these are some of the considerations as well that you need to do as your data grows. If you need to make your data more available, you want to solve problems of faster reads or faster writes, you might want to consider caching. Data partitioning is distributing your data across system to basically improve query performance, right? If your system is very read heavy, you might need to consider data partitioning to improve just like frequent querying and query performances. So definitely something to consider. SQL versus NoSQL. So depending on your system, depending on your users, depending on the data you are collecting, you would want to make a decision around whether my data that I'm collecting and storing, should it be relational data or should it be non-relational data? You can do either and you can do both. So it depends on the nature of the data and the functionality. And based on what your decision is, you might then want to pick an underlying technology, right? Should I choose SQL or Oracle? Should I choose MongoDB or some other application, right? Is it column-wide store? Or is it document-based store? So these are some of the things you need to research, and these are some of the design trade-offs you need to consider. Performance. So performance is basically your application is glitch-free and fast. Again, glitch-free, you need to, it's subjective. You need to define what a glitch is and how glitch-free and robust your application is. But this is something that is subjected to the system and the application, and you need to come up with this, and you have to also determine how fast your systems are, right? Like how fast is data loading, how fast is querying, how fast is your API calls. So you need to come up with these metrics as well. Extensibility. So this is basically every time you design a system or build something from scratch, there's almost always this assumption that the system will grow, the data will grow, you will add more functionality. So from the get-go, you want to build something that's extensible, that is maintainable. If you want to add new features, if you want to deprecate current features, all of that happens with minimal effort, and it doesn't require you to redesign your entire application or create a lot of tech debt for you to even add any new features as you grow. So you have to think about extensibility as you design a system and software applications. Error handling again, and security. So this is of course, the data you collect from the user, you have to think about validations, you have to think about error handling and exceptions, but you also need to think about security and privacy, like how secure is your data collection and storage? How secure are your sites or applications? What does privacy mean, right? Like, are you collecting the kind of data or functionalities that you're providing require you to think about vulnerabilities? Do you need to authenticate a system? Do you provide authorization? If yes, then how would you design these things, right? And the best practices around it. So you need to think about these things as well. Here is just an example of in the picture is just a simple diagram which just shows a very basic system design diagram where a user just for the user, you load pages from CDN, and then there's a load balancer, which handles traffic from different servers. And all these servers communicate with like a queuing system, a database, or a cache. And then there are like streaming workers as well. One thing I need to mention when we talk about system design is what is high level and low level design. Like these are terms that engineers usually use during system design discussions or design meetings. And I felt like it would be important to just quickly mention what these terms mean. So high level design is your big picture stuff, your big picture explanation of, like your different system modules, the functionalities you're providing, and the relationships between data or modules or different functionalities, right? So this is like the top level view where you are not yet detailed enough, but you basically understand what you're building, what are the different modules, what will your interface be, what functionalities are you going to provide, what is the relationship between different data and the flow of data through your system. So very big picture stuff. This helps engineers convert business requirements into technical solutions, right? If your product manager comes and tells you, hey, we need to build this feature, now you can do high-level design to map that business requirement into a technical solution and help you understand the current system, how you're going to build a new feature, and any challenges that you have and how you're going to address that. So this is what high-level design helps us understand. Like I mentioned, here you define the functionality and the corresponding data flow through your system. It can also be you need to integrate with different external systems. So what would that data flow look like, the security look like, APIs look like? That's something also you would want to, at a very, very high level, think about. Focus here is on system architecture, the big picture stuff, not necessarily drilling down into a specific module and in detail designing it and discussing what the requirements would be at the development level, right? Here you're still doing design. You have not started development, so it's not detailed enough. Low-level design would be the next step, where you actually look at the detailed implementation based on the high-level design that you have come up with. So now you need to understand, what does each module design look like? How are you going to implement a functionality? How are you going to add tests, right? How are you going to basically add documentation, stuff like that? This is very, very detailed to a point where an engineer would know what they're supposed to do, right? How to actually execute and code this functionality. So that's the detailed low-level design. Here you need understanding of different tools, technologies, and configurations. So you might want to pick what database you want to use. You might want to pick what monitoring app you want to use. You might want to understand the configurations between different systems and actually define all this and actually code all this out. So here you need to know the tools and technologies and also be able to use them. With low-level design, you actually, specifically design your URLs. What is your API URL look like? Like, what is the data schema and the data structure you're choosing? How does error handling, exception handling actually happen? So you would want to definitely define these things and document them, because this is what you're going to end up implementing as an engineer. So it's very detailed and it's very specific as well. Focus is on the system implementation part. Like, now we have a system, we have an architecture, how are we going to implement it, right? Like, give me the exact steps, because as an engineer, this is what I'm supposed to do. So you are focused on now implementing the design that you came up, the high level design that you came up with. Next slide. Yeah, so I'll talk about a couple of things in this session. First is front-end architecture and next will be backend. I felt like when we talk about system design, no matter what your background is, some basic knowledge of what front-end architecture is and backend architecture is important. You can consider these slides as recommendations of most of the things that you need to think about when you focus on front-end or back-end engineering, and then you can use this as a template to, you know, do your own research and actually understand these concepts in much detail. But the goal here is, if you're thinking about front-end engineering, some of the concepts you need to know, some of the technologies you need to know. So this is what the next few slides actually would be. So front-end architecture is basically development of graphical user interface for interactions with users of a website, right? So there's a client or a user, you are providing them a phone app or a website or a web view and some kind of user interface that they would interact with, they would engage in, you know, and that is what you're developing, something that a user, people like you and I are going to interact with. Right, so that is what front end is, and there are some of the things we need to keep in mind, or at least understand some concepts and technologies when it comes to front end. So some of the things we need to understand is like networking and internet protocols, like HTTP. We need to understand, you know, how different systems this is core computer science, like how different systems and computers communicate, right? What are some of the internet protocols, HTTP, IP, TCP? You need to understand these OSI layer, very basic things about networking that is nice to have knowledge if when you are thinking about front end or even building something on your own. So knowledge of networking and internet protocols becomes like crucial, and that's the first thing. That's why I mentioned it. Content delivery network, or CDNs, are basically distributed servers that deliver web page content. So these are geographically located distributed servers that help deliver web page content. It can be something like, you know, text on the content or even images. It helps you load these resources quickly, and that is what CDN does. Web design, you need to understand like graphics, right? Like what does a beautiful website look like, right? How can you create good graphics? How can you edit graphics for your website, right? So understanding web design becomes crucial. Accessibility is when you make your websites accessible or comfortable for people. It's usually for people who are disabled, but there are like four core rules where your website would be considered accessible if it's perceivable, operable, understandable, and robust. So these are like the POUR. This is like a standard for an accessible website. UI internationalization. So basically your site should be supporting localization, right? So it should support localization across regions, cultures, and languages. One good example of this would be, you know, if I'm clicking on Amazon.com here from the United States, then it will show me, you know, the content would be rendered based on the region I am in, right? If I go to, let's say, Peru, and I click on Amazon.com, it might show me an Amazon Peru website. The language might change, the kind of products I see might change. It might not show me the products that are sold in US. It might show me the products that are sold in Peru, right? So Amazon supports localization, and your website, depending on your product and your website, you want to support localization as well. Server-side rendering would be basically converting server-side HTML files into fully rendered HTML files, which then your user or client would see. Full text search is ability to search text instead of extensive data sets, and that's something that also is a core feature or consideration when it comes to front-end architecture. Lazy load helps you basically improve performance, where you want to delay loading certain resources on your website, and this will only help you improve performance and maybe even reduce some costs. So you don't want to always load an image, you don't want to always load you know, text. You might want to do some kind of paging. You don't want to load all your results in one shot, because this may slow down your performance or your website, right? So you have to think about performance as well. Responsive design and browser compatibility. This is basically your website resizes based on the device, the browser compatibility, the screen size, etc. When it comes to responsive design, that's where your site might adapt to the device, the screen size, etc. Browser compatibility would be you don't want to support an older version of a particular browser because there might be security vulnerabilities or some other issues with the browser. So you have to know what different versions of browsers are available. If there are any security vulnerabilities, you might want to address that as well and make sure your site is secure and it's compatible with, let's say, the top browsers like Chrome or Firefox. Web security, very important topic. We build a website or an app, you need to think about denial of service, even distributed denial of service, SQL injections, JavaScript code injections, XSS. There are a plethora of vulnerabilities, in the front end side, and you need to understand what the different vulnerabilities are, and you might want to address them in your backend code as well as your front end. And knowledge of web security, privacy, user input validations is very important. When we talk about front-end architecture, I felt like mentioning some of the tools or technologies in the tech stack is crucial. Most of you here know what an HTML is, right? It's a hypertext markup language. It helps us determine the meaning and structure of our web content. CSS helps us style these contents. JavaScript is scripting language for defining functionalities. Most of these front-end technologies or languages or frameworks definitely support object-oriented programming. So knowledge of OOPS principles is very foundational. Document object model is viewing the document as a logical tree of objects, of data objects, where these objects are considered node in a tree. This helps parse through the document and very quickly. Web browsers, like I mentioned before, knowledge of the top web browsers, their different versions, any kind of security vulnerabilities or security patches that these respective companies are pushing to their browsers. Knowledge of all of that becomes important because these browsers, they keep on pushing new and new updates and new functionalities, and that's something you would want to accommodate for. Web views is basically, this relates to native applications in iOS or Android, or even Windows actually, where your native applications are rendering a single tab of a web browser, right? So you would want to, if you're building native applications for these platforms, you would want to, you definitely are designing web views. And there are a couple technologies that I mentioned here that help you develop web views. First is like Cordova, if you want to build a phone or tablet application, and Electron for building desktop apps. Frameworks, there are a lot of frameworks out there. These frameworks basically help you with building multi-platform front-end applications. And also there is support for backend, so you can test your code end-to-end. So a couple applications that I can mention is Flutter or React Native. These frameworks, React Native, I think is by Facebook. Basically out-of-the-box applications that help you with front-end development. You also, as a front-end engineer or someone who is interested in this field, need to know developer tools. One good example is the Chrome developer tools. Literally, you can look at your caching data, you can look at your APIs, response and requests. There are a bunch of different things. You can see even performance, even errors on your JavaScript or CSS side. You can even traverse the DOM. So like these developer tools help you test and debug your code right away. And in my experience, they're like really good tools to simplify your front-end development. Documentation here is for the product and the process. And as an engineer, I think documentation is very important. And that's something that you should always do for your process or your product. And even if there is any engineering practice, you would want to write a playbook, and you might even want to document that. So it becomes crucial. In the image here, these are just a different kind of JavaScript frameworks available. You can there are pros and cons. You can compare these applications depending on what you're building on your own or as a part of a team in a company. And you can have understand your trade-offs and choose the applications the framework that you want. Backend architecture, we already talked about what backend is. Some of the things to keep in mind. Backend is actually quite comprehensive. There are more things that I could mention, but slide is just limited. But some of the most important things are like understanding of microservices and actually monoliths, where microservices basically, monolith, let's say, is a big application which has 5-10 different functionalities, let's say, and it's all one blob of code that is deployed, and that's basically a fat jar that's deployed, and it comes with its own set of pros and cons. Microservices is more structured, it's more modular. These are basically individual loosely coupled services where each service has a functionality rather than one service or application having multiple functionalities. And then you design these services, and then you design the interfaces or communication between these services to build your product or your feature. And this design would be considered some kind of system design, right? Because you're designing an entire system consisting of different microservices. APIs, application programming interface. This is communication between systems, right? It can be communication between two backend services. It can be communication between your front-end website and your backend API. But this is basically a communication contract that you need to define between two different systems, between a front-end and a backend system. Data types and modeling. You need to select the kind of underlying data structure you want. Is it a data structure that's available already? Is it a data structure that you have custom designed based on how complicated your systems or functionality is? But you need to design your data or pick your data structures, and also come up with relationships within different data, right? If it's relational data, what does the relation look like? If it's non-relational data, then how are you writing this data at different points in your system, right? At different points in the user flow. These are some of the things that you need to actively consider and design when you are doing backend architecture system design. Exception and error handling, we talked about this. We want to think about the normal execution scenarios of an application, right? So that would be the happy path, and also the abnormal application scenarios, which would be the unhappy path, where some error happens. It can be something within your system or external, but you need to come with a list of these happy and unhappy paths and exceptions and errors, and come up with the solution on how we would address these issues. Logging and monitoring, pretty much every system these days, or every good system this day has some kind of logging. It's usually logging an event in time, or a user behavior or user interaction in time. You're basically saving events, right, in real time for analysis. And monitoring helps you understand the health of your system. So you have certain services running in production, up and live, and you just want to make sure that these systems are healthy and in good standing. And that is where monitoring helps you. Monitoring will also help you understand if a system is down or some glitch or something happened, and how to go about fixing it. So this is very real time health monitoring. Notifications, depending on your product or your service, you might want to design a notification system around what you're building. And if that's something that's required, then it's basically timely alerts of user activity or system activity. Configurations, you would want to define how the system is configured. It can be behavior, it can be resource management, and its boundaries, right? So limitations around how your system is supposed to perform and how your functionalities are supposed to be executed. And this can change. Configuration can also mean you are now integrating with a third-party application, and you need to define what that integration or interaction looks like. That is also something that would be considered configuration. Automations, so you would want to have cron jobs or Jenkins build jobs or some other kind of build jobs, which basically are done for some kind of periodic maintenance. Or it can be anything from some periodic maintenance for the system, or it can also be something where periodically or regularly your data is being fed to the database, or some kind of backend data processing is happening, and you would want to automate that. So that's why cron jobs or build jobs can be very, very useful. CI/CD is continuous integration and continuous development, where you focus on code merges and automated testing, and basically shipping or deploying your applications faster. Security and privacy, we talked about that. Security would be safeguarding your data and your applications or your system. And privacy would be, if you're collecting user information, you know something about user identity, then you need to think about privacy and how you persist this data, and what is your policy and compliance when it comes to collection and storage of user identity data. That would be privacy. Scale, we talked about this. Manage application demand needs. As your application grows, you need to think about performance, you need to think about scale, and you need to make sure that your application is able to handle the growing demands. Cloud architecture, almost all companies these days are using some kind of cloud architecture, right? So we need to think about what the technology would be. Here in cloud, basically, is you are sharing your data across, sharing and storing your data across networks, right? So you need to think about what technology you would pick, what does that implementation look like or integration look like, and then also costs around choosing these tools and technologies. Data streaming, again, it's very up and come, well, for a few years now, but like almost every company is now looking into some kind of automation data streaming, where you have real-time data collection and processing. And that is what data streaming would be. Networking and operating systems, it begs to mention front-end or back-end, some knowledge of core computer science, networking, operating systems, data structures and algorithms comes in handy when you are designing systems and when you're thinking about scaling and growing your applications. Here is just a diagram of a little bit about what backend is. You know, you think about server-side applications, you think about database, you think about the tech stack and programming languages, and you are also focused on designing and implementing or building your APIs. Some of the technologies, the list is huge, but some of the technologies, I tried to be diverse to here. Some of the technologies that would be considered backend side or help with backend development would be, you know, PHP, hypertext preprocessor. It's a very classic old language, still in use, and it's a scripting language to develop web applications. New and new versions of this language keep on coming. Python, all of us know about Python. It's primarily used for data analytics and machine learning, but it can also be used to build backend features. Java is an object-oriented programming language for development of web, mobile, tablet, gaming applications. The list is huge. MySQL is a relational database, right? BigQuery is when you want to do analytics on big data, as in like large data sets. This is a warehouse that helps you store and do analysis on large data sets. Cassandra is your classic non-relational database. So this is one example of non-relational or NoSQL databases that you would want to consider. Again, there are different kinds of non-relational databases, a column-wide, a graph-based, or a document store, etc. So you want to first understand how you want to structure your data, what does the core data structure look like, and then pick the different tools out there that you would want to compare and then select. You want to compare the performance, query performance, read write efficiency. You want to also think about licensing and costs. So these things you have to consider. Docker, I think pretty much everyone knows about Docker. It helps you build, test, and deploy applications much faster. JavaScript, one example would be Node.js, right? It's a JavaScript framework that's used for backend development. AWS is one example of a cloud infrastructure that helps you manage your data and infrastructure needs. Jenkins and Circle CI, these are basically automation frameworks that help you build, test, and deploy your applications. GitHub and Stash is your source code management. New Relic is a really good dashboard system for you to monitor your applications and understand observability as well. Postman is for API development and testing your APIs. Nginx is your web server management platform, and Wireshark is helps you view and troubleshoot your network traffic, and also at the very detailed level do your network traffic packet analysis. Here is a diagram of some of the things that come in under the purview of backend. This core system architecture, you need to think about different kinds of servers, application server, web server, etc., databases, security, frameworks as in different, like basically your tech stack. You know, think about security and privacy. How would you implement your business logic in the backend, right? Data analysis and storage. You need to know operating systems, because you might be building your application for different systems, and scalability, of course. Yeah, here is just next few slides are just few diagrams on when you it'll just help you visualize a system design, right? This visualization really helps. And when people are giving, like engineers are giving system design interviews, they almost always draw some kind of diagram. And this is just an example of a system design, right? You have your clients. To the left, it can be a browser on a laptop, or it can be a web view on a phone, iPhone or Android also. So that also is different. You have some kind of web server, which might be, there are more things here, but just web server helps you route traffic. You might want to do authentication. You might want to authenticate your user using some external third-party service. Then once the user is authenticated, you would they would have access to your APIs. There's caching here. There is data storage. In this diagram, it seems like you might be dealing with like a lot of data. So there is some kind of batch processing, and then data gets persisted to your data warehouse, because here this application is dealing with large data sets. This is a different kind of system design diagram. Here, this is a little bit more detailed or more mature of a diagram, where you have different systems. Here to the left, different clients, and their behavior is slightly different, right? So like the third client to the left is dealing with a CDN in the United States, whereas the first one and the second one dealing with a CDN in India. So the geographic location changes. So these two, the first two might be devices or clients in the India or Asia region, and the last would be in US or North America region, right? The traffic from these different clients or devices is load balanced to your application servers, authentication servers. There's a queuing mechanism here. So there's a pub/sub architecture implementation, and there are workers to enable that. And this is a very data heavy system. So, you know, you can see there are more reads than writes per se. There's caching. So yeah, depending on how your system is, what kind of data you're dealing, how much traffic you are handling, what are your trade-offs, what are the performance requirements. It's all subjective. It's all things you need to consider, the trade-offs, and also based on your requirements, all the things you need to determine and make these decisions. And then you can come up with a system design. Here you can see, you know, there's a master and even a slave databases, and the reads and writes are also redirected accordingly. So this is very detailed in a way, and even at this level also you can determine how your system architecture should be, and how would you want to implement, and based on this, what technologies you would want to pick. One thing I need to mention is when you're doing system design, for you as an engineer, even if you're giving an interview, you know, even as an architect, there are some core skills that are assessed, or I guess necessary, when you are thinking about system design or system architecture. First one is problem solving, right? Like in the real world, usually corporate jobs product managers just come and tell us, hey, we need to design XYZ feature. That's it. And I, as an engineer, have to look at, okay, what system is this, right? Is this even doable? Do I need to first resolve a tech debt? If I don't need to do that, do I need to build something from scratch? If not, how do I modify an existing system, right? What does the timeline look like? This is a core skill in engineering anyway, which is problem solving. So doing designs or system design is an exercising of your problem solving abilities. Attention to detail becomes very important, especially when you are doing low level design. You really need to understand your data structure, your APIs, how the systems interact. You want to think about all the considerations that I have mentioned before and in detail, depending on how critical your systems are. So definitely you need to have very detailed oriented thinking. Conceptual understanding of the tech stack. Like I mentioned before, right? Should I pick relational data or non-relational data? If non-relational data, which kind? Column wide or graph? If graph, then which tool do I need to pick? What does my tech stack look like? How do I integrate with that application, right? It's a third party, or it's something that my company has built internally that I need to integrate with, right? So conceptual understanding of different tools and technologies, which is basically your tech stack, becomes crucial as you do design. And if you know a few tools and technologies, great. If you don't know, that would be a learning curve for you as you design. Working with technologies at scale. So like I mentioned, right, you almost always assume your application will grow, it will have more functionalities, it will deal with more data. So you need to be very comfortable with the concept of scale and all the trade-offs that come with it. And you need to determine what application execution looks like, what performance looks like, what are your trade-offs, right? So you need to understand scale and be very comfortable with it. The technologies, the decisions, functionalities, requirements, business side of requirements, everything. Planning and collaboration. Of course, you're designing something, you need to also understand the timelines. You need to also come up with a plan on how much time the design will take. What would the execution look like? What different teams or people do we need to collaborate with, right? Is it something that can be done within your team? Are you using a very different third-party application? Then you need to actually work with people at that company who are, who have built that tool. So you need to collaborate with them, right? So planning and collaboration is also becomes a very important skill because you need to know that the design that you are proposing is feasible. If it's not feasible, then you might need to alter it, right? So you need to come up with a plan and also understand the resources around this and how would you make your design happen. Yeah, so we are at the end of our session. In a few minutes, we'll open to Q&A. This presentation was just very high level, simple understanding of what system design is and what front-end and back-end is. We will look into the design considerations that I mentioned in much detail with examples in the next session, which is on February 23rd. So do RSVP for that. And the session after that would be interview questions. This is interview questions that engineers are asked during software engineering interviews, during the system design rounds. And we will I will talk through some questions and we can also openly discuss some. So this is 3 sessions of the system design 3-part series. And there are some other resources here that you can also refer. This presentation is available on Women Who Code Backend Study Group GitHub. And so feel free to refer it, download it. This meeting would be recorded and available on YouTube, on our Women Who Code YouTube channel as well. Now would be a good time for Q&A. I'm seeing a lot of chat messages actually.
Yeah, I responded to most of them, and people are just discussing amongst themselves. So Rupa then asked, could someone, not that one, can someone please tell me what a framework is in simple terms? I think that was.
Sorry, can you repeat that?
Can someone tell me what a framework is in simple terms? I think you were talking about frameworks as a part of the front end thing. So Rupa has a question on that.
Yeah, frameworks is basically, it's an umbrella term. It's a set of technologies or tools that help you develop something, right? So if you need to develop a code and application, there are different kinds of functionalities you need, and a framework kind of makes all of that happen to you in just like as a part of like one application or one tool or one system. So framework is an umbrella term that helps, gives you all functionalities to develop your applications. I am reading the chat. Yeah, Django is a good example. Feel free to unmute and ask as well, or put in the Slack channel. We have 9 more minutes. So feel free. If this is it, then I hope you guys RSVP for our next session, the next 2 sessions. And there's a lot more. This is just tip of the iceberg. So a lot of exciting stuff to discuss in the upcoming sessions. And I hope I'll see you guys there as well. Harin and I will be here for the next 8 minutes for any Q&A.
Can people now unmute if they have questions, or should they raise the hand? And
I think you might want to raise your hand.
Yeah. No questions, folks.
Thank you. I have one question from Claudia. Yeah, can you talk more about database design choices? Yeah, sure. Couple of things I already mentioned, right? Relational versus non-relational. So you need to start there, right? But for that, you need to understand your business case. You need to understand your requirements. And you also need to understand what your current technologies actually look like, right? So start there. And based on relational and non-relational database, relation is fairly simple. There are MySQL, Oracle, Postgres, different kinds of tools or technologies for relational databases. You can just compare the query performance. You can compare indexing capabilities and then licensing and cost. And that will help you determine which relational database to pick. When it comes to non-relational database, definitely similar things, but depending on if it's column-wide or graph, you would want to first drill down on that. And depending on what kind of non-relational data structure you choose, you want to also consider trade-offs, right? You want your system data to be more consistent. You want it to be more available. There's a CAP theorem that you can look up, and based on different databases, non-relational databases address these design trade-offs in different ways. So that's something additional that you would also want to consider. I hope that helped. Lazy load is front end.
Lots of questions.
Yeah, lazy load is front end. Or at least I mentioned it in the context of front end. Yeah.
Claudia has asked, at what point do you decide to create multiple databases or multiple copies of databases?
Right. So one example would be Instagram, right? Like I want to store my user information in a relational manner, let's say, right? I'm just storing details of, oh, actually, let me correct myself. Facebook, better example. In Facebook, right, you have all these different people who are connected to each other, right? So the data structure there would be a graph kind of database, right? A non-relational graph data structure where each node is just a friend I'm connected to, right? So that's one data structure. But Facebook also has videos and photos, and you would want to store videos and photos in a document kind of data store, right? Which is separate. So for Facebook, you have different data bases that are supporting your entire platform or product, right? Where each kind of data is a different data structure altogether and corresponds to a different technology or a different data type. So that would be one example where you might want to choose different data structures or different databases as well. I hope I answered your question. Awesome. If I'm missing any question, please like mention it again. There's too much chat activity, so bear with me here. What tools, technologies, methodologies do you recommend for building HLD and LLD? So Miro is a good app. It can be as simple as whiteboarding. It can be as simple as just drawing something on paper, you know, like it should be free flow. You can pick a very sophisticated design application, or you can even do it in your Google Doc or something. It really depends. I would not say there is like a hardcore expectation requirement around it, as long as it's very clear. Like the diagrams I showed, right? It can be something that someone drew on a whiteboard. So as long as it's clear, descriptive, and detailed, any application or drawing tool, I guess, design tool should be fine. Okay, I don't see any more questions. If I missed any, just mention the question again in the chat and we can talk about it. Did I miss any, Harini? Any questions?
Can you please give the name in the chat of the app? Which app were you talking about now? Because I can just send it in the chat.
Oh, good place to start learning backend on own. Look at that slide. That's something to begin with. There's two parts here. One is theory. So basic understanding what security is, privacy is, what databases are, and stuff like that. A little bit theory, but the best way is to actually start implementing. So download a few applications and start learning. Like one thing you can start with, like I didn't mention in the presentation, but a MAM stack or a LAM stack, right? You can consider these technologies and just download a few frameworks or applications and just start coding out things. Best way to do something is, best way to learn something is by actually coding or doing, so start there. A whiteboarding app, that is Miro. I think it's Miro.com. But there is also whiteboard.io or something like that. Yeah. Cloud services, good question. Okay, so if there are two ways to answer this. If you're an independent developer, you don't necessarily need to. But if you are working at a company, there might be two ways your company is storing the data, all your data. One is on-prem, so physical servers on premises, right, in your office or something. Other is on cloud, right? So distributed servers, which are globally distributed servers, right? So if that's something that your company is moving towards, or that's something that they have, then you need to understand cloud. And when it comes to cloud, you need to understand if it's AWS or Azure or something else, right? So depending on how your company is storing the data and what technology they are supporting, you might need to educate yourself on these things. Again, if you're working a product or a project where there's nothing related to cloud, you're not dealing with data on the cloud, then you don't need to. So if only there's a requirement where you are integrating with AWS or different kind of cloud infrastructure systems, then you really need to understand what that integration looks like, what does system design and architecture look like, because that will help you develop more and more integrations with these kind of systems. You're not going for DevOps path. You don't, this is not DevOps, this is backend software engineering. DevOps would be more infrastructure side, but having a knowledge of cloud and different AWS systems or services is backend. It's not necessarily DevOps. Yeah, Seema, in the next session, we'll talk about authentication and authorization. Yes. Basically, the considerations I mentioned, we will just look into those things in detail. I think we are almost at time. Thank you, everyone. This has been great. I really, really appreciate all of you being here. And I'm hoping to see all of you in the next session as well. This recording will be available on YouTube in the next few days. Thank you very much. Bye.